Hi guys, in this video I explain how to implement merge sort. The first two function prototypes I used to implement the merge sort algorithm. Merge sort is a function that expects a reference to a vector as well as a start and an end index. The merge function also expects a reference to the vector. It requires a start index, middle index, and end index. The print function is used to print out the elements of a given vector. Let's first take a closer look at the merge sort function. Merge sort is a recursive function that takes a vector or array, if you will, and breaks it down into subarrays. The initial array to be considered is defined by the start and the end index. If the entire vector should be considered, start would be 0 and end would be size -1. For example, if the vector has a size of 5, start would be 0, end would be 4. The first condition checks if start is larger than or equal to end. That ensures that there's at least 2 elements in the vector before breaking it down further. If there's just a single element or no elements at all, it simply returns because there's nothing to sort. Line 20 computes the middle value between the start index and the end index. This is computed by taking start plus end minus start divided by 2. The middle value defines the middle index at which to break down the input array. It breaks it down to a left subarray and a right subarray. The next two function calls are recursive function calls. The first function call passes in the left subarray. The second function call to merge sort passes in the right subarray. Specifically, the first function call passes in the vector and start and middle as the index, which defines the left subarray, and the second function call passes in the vector, mid +1, and the end index. This defines the right subarray. Since both of these functions are recursive, they will further break down these subarrays into smaller arrays, all the way until the base case up here is hit, and each input array has just a single element. At the end, the merge function is called. This takes in subarrays and merges them back into a single array. Let's see how merge is implemented. The merge function takes a reference to the vector as well as a start index, a middle index, and an end index. Take a look at the example up here. If this is our vector, the vector has 5 elements, and in this example, I assume that start and end define the range of all elements in that subarray. The middle is the middle between start and end. So in this case, start is 0, end is 4, the middle would be index 2. Now, these 3 indices define the subarrays. The left subarray is defined by 13, 24, and 34. And the second subarray is defined by mid +1, which is 11, all the way until the end, which is 31. I have 2 indices, left and right. These keep track of the elements in each subarray. The left one starts at the start index. In this example, it would be 0. And the right one starts at mid +1. In this case, it would be index 4, which is 11. Then I create a new vector that I name sorted. This is the merge vector where the sorted elements will go. And then I iterate over both of these subarrays and compare the elements and push the smaller one into the sorted array. Let's see how this works. So initially I have L at the index of 13 and I have R at the index of 11. As long as L is less than or equal to mid and R is less than or equal to end, I check if the element at index L is smaller than the element at index R. If it is indeed smaller, I push the element at index L into the sorted vector and I increment L. If the element at index L is larger or equal to R, I push the element at R into the sorted vector. Let's see how this works. Let's say I have a sorted vector. Initially that vector is empty. Now I initialized L to start, R to mid +1. L is less than mid, R is also less than end. Now I check if the element at L is less than the element at R. So the element at L is 13 and I check that it's smaller than 11. This condition is false, so I take the element at R and push it into the sorted vector. Then I increment R by 1. So R now refers to the element 31. Then I check again, is L less than or equal to mid, and is R less than or equal to end? This is both true, so I check if the element at L is smaller than the element at R. So is 13 smaller than 31? This is true, so I take the element at L, which is 13, push it into the vector, and then I increment L by 1. So L now refers to the number 24, which is the second element in the first subarray. Now I check again, is L less than or equal to mid, and is R less than or equal to end? This is true, so I check, is the element at L, 24, smaller than the element at R, which is 31? This is smaller, so I push the element at L into the sorted array. So 24 goes into the sorted array. Then I increment L by 1. Then I check again the condition. Is L less than or equal to mid? Yes, it's equal to mid. And is R less than or equal to end? It's also equal to end, so this entire condition here is true. Then I check if the element at L, which is 37, is smaller than the element at R. This is 31. 37 is not smaller than 31, so I enter the statement in the else block. And here I push the element at R into the sorted vector. This is 31. So 31 gets pushed into the sorted vector. Then I increment R. And now I check again. Is L less than or equal to mid? This is true. Is R less than or equal to end? This is false. So this condition becomes false. And now the while loop ends. The reason for this is that there are no more elements in the right subarray. I went through all the elements, so I have nothing to compare to in the right subarray. There is, however, one element left in the left subarray. So the two while loops push the remaining elements in any of the two subarrays into the sorted vector. In this case, I had one element left with L. L was equal to mid. So this condition is true. I push in the element at L and I increment L. So the element at L was 37. I add it to the sorted vector. I increment L by 1. Now L is no longer less than or equal to mid, so this condition is false. Then I check the condition, is R less than or equal to end? This one is false because R went already above end in the previous while loop. So I skip this. And the last step simply copies the element from the sorted vector into the original vector. This creates a counter variable I initialized to the start index, and as long as I is less than or equal to end, it increments I. And then it translates the index. So the sorted array starts at I minus start. Basically, it starts at 0. But for the input vector, the start and the end index define the range where the values should go. So for the input vector, it's always I, because I starts at start and ends at end. But for the sorted array, it starts at 0 all the way to the number of elements defined by end minus start. Once all the elements are copied, the function returns back to the function call here, and that returns all the way to the main. In the main, I created a vector of integers that I initialized to these integer values. Then I call the merge sort function. I pass in that vector, and I say initially in this function, I want to consider the entire vector as input. So this is the entire vector that I want to start out with. And that is defined by the start index 0 and by the end index size minus 1, which is the index for 64. Now when this is passed in, it computes the middle value, which would be the index of 12, and then passes in the left subarray in this recursive function, and then the right subarray to the second recursive function call of merge sort. And then it further divides those down. Now when this function call returns, I know that the vector values is sorted. When I run this program, you can see that I now get the sorted array. I hope you enjoyed this video. Thank you for watching.